Welcome to Get Your FRQ On. In this tutorial, I'm going to show you graphically what's going on when we encounter a radical equation that has an extraneous solution. So typically, the way this would arise is we have a radical equation involving an even root of an expression. Because it's an even root, we can't take the even root of an expression when it has a negative value and expect a real result. And so sometimes what will happen is we have this even root in our equation and we end up applying the inverse. So like we have a square root and we end up squaring it to get rid of it. And that may make a simpler equation for us to solve, but it's not technically the actual equation we're supposed to be solving. And so when we do something like this, like square a square root or raise a fourth root to a fourth power or something like that, we often will get an expression that has x squared somewhere in the equation, or x to the fourth somewhere in the equation, and we would go about solving that like we would solve any other polynomial equation. The problem there is if we had like a quadratic equation, we would probably expect two solutions, or at least we would know that two solutions is possible. But the issue is we get those two solutions from a quadratic equation, which isn't the original equation. And so what can sometimes happen is one of the solutions, or both, of that quadratic equation might solve the quadratic equation, but when you substitute that value into the original radical equation, it doesn't actually work. So you would have to check that using algebra if you were solving an equation like this. The purpose of this tutorial is to just show you graphically what is going on here. So I'm going to use a pretty basic example. I'm going to go to y equals, and we're going to start with the square root of x. So one of the sides of our equation is the square root of x, and the other side is just going to be x minus 3. So really what I'm after here is solve the equation the square root of x equals x minus 3. All right, so I graph this, and notice there is actually only one point of intersection between the line and the square root function. All right, but if we go back to our original functions, what would happen if I squared both sides? Well, I'd get an x for y1, and I'd get a separate quadratic function for y2. And so switching back to the graph, imagine that this square root function, what if we just completed the parabola, the other half of the parabola? In fact, to show you what that would look like, let's just graph it. All right, just to see what that would look like, this sort of upside down square root function represents the other half of this parabola. So if I squared it away, yeah, this line would cross that parabola twice, but remember, the bottom half of that parabola isn't actually part of our equation. So even though, we square something, we get a quadratic, yeah, we got two solutions, whatever, that's not the original equation. If we just look at the original equation, that line doesn't cross that graph two times, it only crosses it once. And so that's generally what's happening when we have an extraneous solution to a radical equation.